smoothly, I really hope. There it goes. Okay, great. So we did a lightning round of Introduction to Logistic Regression with the GLASS predictive data set. Now we're going to do the same thing, but for the Titanic. And this will kind of feed into the app that I showed you earlier, but with some predictions associated with it as well. So again, you can take a look at the solution code. What I'm going to be doing on the screen will be similar, but not exactly the same. Just
create a new one as well?
Yes, please create a new one. Create a new Jupyter notebook. And this one we're going to call Titanic log reg class notes. And make sure that I've got my solution code up here on the screen so I'm not the blind leading the blind. You guys have to ask me fewer questions during the break so I don't fritter my time away. Let's see. The last one I wanted to do was, where was that? Tutorial. Figures. Pandas. Okay, and the imports are going to be the usual suspects. Titanic data classification with logistic regression. So we're going to import pandas as PD. We're going to import NumPy as NP. And our solution code is going to be URL. I didn't mean to turn that into code. That is actually not code with that. That is supposed to be code. Our URL is going to be equal to, and I'll spec this out, HTTPS raw GitHub user content at my name, plotly-tutorial. Master. I use this one because it's already pre-formatted, so it has a lot of nice data cleaning that's already taken place in it. Titanic.csv. I'll run that, and I'll copy that and send it out to you, so you don't have to copy all of that down by hand. And this is going to be in general Titanic data. That's here. Okay, so let's call in our data set as df is equal to pd.read CSV URL, and call it df.head. And hopefully everybody is there. And it looks like we want to call index call as equal to this guy here. Nice. first we need to do a little bit of pre-processing on the data in order to make it usable. So we've got survival, that's what we want to predict. We've got cabin class, that's a 1, 2, or 3. But we'll want to create dummies for our gender and a few others. All right, PD get dummies, and the data is df and sex will create new columns of male and female. There's a way to do this in one blow so you don't have to merge it back into your data set, which is what I'm pulling up here on my second screen. There we go. Sorry about that. All right, so that's what you would do with a single cell, but if you wanted to do it for entire data set, the code is a little bit different. It looks like this. df2 is equal to pd get dummies, and then you put in the name of the data set. You specify the columns that you want to break apart, which in this case is going to be sex. And then you indicate whether or not you want it to have a prefix. It's going to be, and I don't actually want it to have a prefix, and a prefix separator, which I also want to be blank. And then I call a df2.head. And now the sex column has disappeared, and instead we have a male and female column. And we'll want to do the same thing for the embarked. Do the same thing for embarked. See if you can do that on your own before I type it out myself. I'm going to call this one df.3, df.2. And now the embarked column has disappeared, and we have columns for Cherbourg, Queenstown, and Southampton, respectively. Now, do we need to scale this data? It could be helpful. It could be very helpful because fair and age are definitely on different levels. I'm actually going to skip the scaling step because we did go over that last time, and it's not an absolute necessity in this case. They're not on orders of magnitude larger than one another. And in the interest of time, I want to have time for you to actually try building out your own model. So I'm going to skip the scaling with the awareness that in a fully production model, you would want to scale your data, pickle the scaler, pickle the model, and call both of them in the app. So let's go with this, and now we can go ahead and set up our start building our model. So the first step, as always, is to instantiate. And for this, I'm actually going to just copy the code over from my other notebook, our other class notes that we did earlier, because it's exactly the same code. I'm going back over here to the class data. I'm grabbing all of cell 48, and and I'm dropping it straight into my Titanic classifier. And I will also slack this out in case you don't have it at your fingertips. Here is my logistic regression model building code. But instead of glass, right, we'll have to do a few replacements here. Y is now survived. We'll want to drop survival, but nothing else. We have to, of course, import that. Sorry. sklearn.linear model import and I still got a glass sneaking around in there someplace. Here it is, df.
Glass drop?
Yep. What else does it not like in this code? Southampton. Could not convert string to float. There's probably some missing values in there, of course. So always clean missing values, right? So let's find out where they are first. df3, oh, of course, I know, I was using df3, that's why. df3.isNull.sum, no missing values. Then the problem is that I was saying df when in fact I wanted to say df3. I think those are the only two places it appears. And there we go, and that actually worked. Let me pause there. I know that was a lot in a short period of time. See if you can catch up. Hit me with questions. While it's up here on the board, I'll talk through what it's doing, though I think it's pretty familiar by now. We chose our algorithm. This time we're not using k-nearest neighbors. We're not using linear regression. Instead, we're using logistic. Our target variable is whether or not they survived. So our x variable is everything except our target variable, which is why we drop it. We would also have had to drop any categorical variables, but we don't need to do that because we converted them into dummies. Train test split, as always. Fit on the training data, so we named our model log model up here. Dot fit on x train and y train both. But once you have fitted the model, then you only predict on x test. You do not predict on y test. And just as a smell test, take a look at the first 5 and see how you did. Have you run the evaluation code yet? Yeah, the first 5 look good, right? So let's go ahead and grab the same evaluation code which we had over here, accuracy, confusion, and F1. So from sklearn import metrics, sorry? You had an error. Yeah, probably I got that same error and I had to convert df to df3. That's the whole reason we did the convert to dummies, and also here at the previous line as well. Yeah. Did that fix it?
I did the but it's just.
All right, let me take a look. They're not nail, right? So it looks like this row you probably didn't do the dummies on nail. Okay, so df2 is get dummies on sex. Df, you do a df head instead of a df. Okay, that was good. Now down here, this is great, except you also use the df.
So we'll predict it.
And then rerun everything after that.
Thank you very much.
Yeah. So our metrics are going to be accuracy, F1 score, and confusion matrix. And I'm just going to print all of these in the same cell. Print metrics dot accuracy score y test versus y preds. Accuracy of 78%. So, given that this was a 3-minute model, that's not bad.
You can quit there, right?
Absolutely. Quit and go home. F1 score, a little bit lower, which is typical. Your F1 is almost always going to be lower than your accuracy, but it's almost always going to be more accurate as well.
What is an acceptable percentage of accuracy?
Come again?
Acceptable percentage.
An acceptable percentage.
Yes.
So that very much depends on your content area and your client. If you're able to get an accuracy of 50.1% and you're predicting stock market values,
It's not over for me.
actually it is. From what I understand, and I'm not an expert on this, anything better than a 50% accuracy will make you money on the stock market. So that's actually considered really good.
Coin.
No, it's slightly better than flipping a coin, right?
Right?
And there's money associated with that, a lot of money, right? But if you're dealing with medical predictions, if you're trying to predict, disease, you need to have a really high accuracy or people will die. So it very much depends on the field. In the social sciences, anything between 60 to 80% accuracy is a dissertation.
So it all depends.
Yeah, it all depends. But I would say, as a very rough rule of thumb, anything lower than 65%, you're going to get an eye roll. And anything higher than 90%, you're probably overfitting. And then the last one that I wanted to print was my metrics dot confusion matrix, also on y test and y preds. Look at the diagonal. Diagonal is bigger than the outliers, but we are making some mistakes in there. There are some people that died and we said they would live, and vice versa. And what about the coefficients? So log reg is our model, or I think it was called log model. And it has coefficients. And it also has predictors, whoops. And if you put them together, list zip x columns and list log model coef x columns b class. What did I do wrong here? What did I do wrong? I think it's this. Well, anyway, I'm not going to spend a lot of time on that. The point here is that we've got a list of predictors, cabin class, age, fair, male or female, and we've got a list of coefficients. And you would interpret each of these as the impact of the coefficient on the outcome, which is survival. So as your cabin class goes up by 1, from first class to second class to third class, your probability of survival goes down by about 9 percentage points. As your age goes up, your probability of survival goes down. As your being male or female, so for female, that is 5 back, right? If you're female, you're more likely to survive. The difference here is that these are actually odds ratios. They're not like linear, it's not a linear relationship. Instead, it's the odds of survival.
But isn't that the reason why we combine, let's say, class and sex? Because based on how they were actually coming out of the ship, it was basically based on what?
Women and children first.
Children based on class.
Right.
And then,
First class, then second, then third.
And then males.
Yes.
And that was also based on class as well.
Exactly. So that's exactly what you would expect, that men would have a lower chance of survival, and men in third class would have the absolute lowest chance of survival. So it's cumulative. But that's what our coefficients are telling us, is for each one of these predictors, what's its isolated impact on
I think
that.
the one thing that, I don't know if somebody ever looked at it, was how long did it take for the ship to capsize the time? Because time would be important. How long would it take somebody to be better in third class to get up the way to the top of the male?
I read about that once too. Yeah, I wonder how much that would be true. I don't
Because
know.
ultimately, I mean, if you've been on a cruise ship, to move around it takes a while. It's a big ship.
Yeah,
So now they have 6, 7 floors above and below. You know, to get down to that surface level, how long does it take?
yeah. I saw an article about precisely that topic. And again, it's kind of fun to take one of these educational data sets and kind of wring it dry with that. Yeah.
But didn't we establish that the higher was all the
Yeah. Now these are all going to be close to zero because odds ratios, they basically range. An odds of 1 means your odds are even. If men and women both have an odds ratio of 1, they have an equal chance of survival. Anything lower than 1 means you're probably going to die. Anything higher than 1 means you're probably going to live. So that's how you interpret odds ratios.
So the average we got here is like 8 numbers, but why the one got is like 9 numbers?
Because you probably forgot to drop survival from your model. All right, so let's go ahead and pickle our results. Just as we did earlier, we're going to go ahead and take that same pickling code that we had in the other one. We're going to pickle our model and make new predictions. And this time I'm going to call this my Titanic model, so it doesn't overwrite my other one. And then let's pretend we're in app.py. And we would want to file equals, instead of write bytes, we're going to read bytes. We'll call this my model is equal to pickle.load file, and then file.close. Keep in mind, here's our first row of data. So what does one row of data look like? And this is going to be open the pickled grained model. What does one row of data look like? It looks like that. Let's make up some fake data. Let's make some fake data. So we'll need a list. Let's put them in third class. Their age is going to be really old. Their fare is going to be really low. They're definitely male. And I think Southampton was the one most likely to die. So with these results, I'm going to call this gonna die is my new data. Okay? And then I can do my model dot predict gonna die, and if I did that correctly, it's gonna be 1. What do you guys think? Oh, snap. Has 7 features expecting 8. I left one of these out. Right, because if he is male, then he is gonna be not female, that's why. And that is did not survive, right? 0 means he died, that's correct. So how would we create data that might survive? One of you guys give me some numbers here for a new person gonna live. Tell me, what information should I put in?
1,
Female.
25.
Has to be female.
Probably.
Which one is female? What about,
Switch to male, female.
or what about fare? What do you think they should pay in fare?
100.
$100 is pretty high. So let's switch male and female. She's a woman.
Yeah. Just
And then I think the French ones were most likely to survive from my analysis. So they're going to board in Cherbourg. And this time, instead of gonna die, I'm going to put in gonna live. And hopefully it'll come out as a 1. And it did. So our predictive model works, right? And then you would build your app around that. So far, so good? Okay. It is 8:46. We got 45 minutes left. With 45 minutes, I'd like you to try one of two things. Either take this and build a Plotly Dash app around it, or take a new data set, such as the NBA players data set, and build a logistic regression model. One of those two things, okay? The NBA data set is just one. You could have picked anything. You could have picked one of the two that we have here tonight. But try building your own logistic model and making predictions, or using one of the ones we did tonight, but build an app around it.
If we do standardization in this case, we need to pick all the standardizations, like all that things first to predict on the data.
One more time.
If we couldn't do standardization here.
If we were to have done standardization, so we go back up here and our data looks like this, and in fact, 71 is much bigger than 38 or 1. So maybe it would have been good to standardize this, yes.
In that case, we need to pickle that standardization.
Yes, you do.
first.
You need to pickle the standardizer.
And you do that before you transform
Yes. Okay. Would it be helpful if I reviewed that?
So it seems like in real cases, it's almost.
You would need to do that?
it.
Well, not in this case. The truth is, in real cases, when the scale is radically larger, the truth is, even 100 to 1, this still has some predictive power in it, as we saw in our app just now. But it would have had more power if I had standardized it. That scale, yeah.
And in general, best practices would be to do your trait test before you do a scale.
Yes, definitely. Again, that's a shortcut that I'm doing here for the sake of a classroom, but in a project, you would not want to.
And you would scale them independently. But
You would scale them independently? No.
No,
You would use the training data scalar on the testing data. But any other pre-processing, such as dummies, you would have to do that twice.
Question for any data we take, you just want us to recreate this last 4 cells that we did here, right?
Down here, yes.
Okay.
Yes. Yeah. This part here?
The missing data.
That was here.
Well, there was none, right? Yeah.
Yeah, it was actually, there is no missing data. I actually did that in my,
No, it's, you have to change the data frame to prove it, yeah?
Yeah, the data find one.
you found a missing data? Which variable?
What's the losing?
I mean,
It's a challenge.
One and name 0.
Let me take a look. And probably the reason why is because the one that comes with the repo is different from the one that I have saved in GitHub, because I need to clean it before I save it.
So I didn't see it here. So I have here our data.
Yes. So the reason you're getting that is because of this. Let me show you my code and you'll see the slight difference. So when I read in the data set, I indicated that the column unnamed was the index column. So it actually becomes this. My guess is that your code doesn't have this
I
line.
don't have that.
Yeah.
Okay.
Yeah, this works. And then later, I didn't write down, so six, no.
Okay, the matrix. So,
Cover all of this.
oh, you need to print. You need to
And when I put the
and
print,
then-
it's the same.
It's the same.
Yeah,
Whatever it
same.
is, the actual file is your decision. It's three pages too small. So
It's still saying the same.
it's to
Right.
see what you-
So this is at the high.
Wait, the first one came.
You can have three
But
judges.
it's still the
I
same.
mean, this model is a judge.
Is a judge.
Oh,
I put L.
Let's go through it.
Okay, that works.
No, okay,
And
yeah,
then
that's all.
later
That's
it's
what I wanted.
word.
And sometimes you can get
I
very
think
different
it's-
scores.
Knowing the shadows,
Yeah, well,
just knowing everything, understanding what each thing
It's
does.
hard.
the other thing I actually noticed.
This is
really
just a
interesting
coefficient.
So you were mentioning like the accuracy scores.
Yeah.
And the next one is just the column names. So
So,
usually it
I've
doesn't
been doing
matter
this since
much.
college.
And then you need to
Second nature,
import
yeah.
people.
I know what I'm saying, because you're gonna build mine from the right.
Where's
Right.
that?
It was in, KK
Yep.
years.
And then
Here.
you would read it if it would be at 5 or not, so it doesn't really matter. But then this one is important then, so here you
yeah,
have
it
that.
Because
And
Definitely.
then
So,
in between
I would
you
expect
need data
Yeah, I have
that you
it.
have,
because there's a single
and
variable
then my model.
with how it's organized, and how the events organized, where
I would just run it
so basically-
from the
Beginning.
beginning, in, yeah.
traditional player was more well known, was a champion, and then qualifications and better player. So if you just put it in red corner, you have a 68% accuracy on some.
Just to throw other
Because that
There
means
you
literally you can just aggregate red corner and you have 67%. 67, 68. So the goal is to beat that.
So that's your baseline. Okay, that's an interesting baseline. Yeah, that makes sense. Higher in chance.
Well, higher than base.
Higher in base.
I know,
Wow.
I know why,
This is
because,
higher than
Wait,
base.
there is
because
something.
my list something
That's-
here, it's, I get one more.
You have
random,
another question?
Yeah.
Or I
Oh.
I don't want.
0, and I have 11.
So this has to be 1, 2, 3, 4, 5, 6, 7, 8.
Oh, no, I'm talking about this one, so,
There's a space.
so.
Ah,
I have
oh,
one
okay,
more.
here,
And
yeah.
I've already jumped.
Maybe you didn't drop it when you
Yeah,
create
drop it,
the
yeah.
Because that's the name of the column.
drops.
The name, the column is named.
Is it,
Oh.
I
is
think
it not casual?
No,
I
it's
wrote-
just,
and then
no, that's,
the column down
no,
is
this is how you do it.
the column name. There's a
Yes.
space, drops, and the 0 is the content of the column.
No, it's, 0 means this is the first column that has no name. Just Python always starts kind of with 0.
Yes.
So the first
Thank you so
unnamed column is column 0.
Ah, okay.
And if there's more than one unnamed column, it's unnamed 1.
So if you don't know, just make it be okay. If I example using the data, so I would just I don't know if there's an missing or a name data, a name column name. So can I easily do the export and name? I don't know the way
No, because if there is no unnamed column, then you'll get an error.
Ah, okay.
This only works because there is in fact an
So I
unnamed
have to check the data first.
column.
Okay.
Does that actually work if you, like, if you have several unnamed columns, you can just reference that?
So if your column has no names,
Yes.
then pandas will give it a name, which is unnamed. So.
Okay, but if
And then you can go ahead and reference
So
it.
yeah,
Yeah.
so if I want unnamed 3 is one.
Yeah, and that is in fact the column name. Yeah.
So I draw the unnamed column here, and then,
Yes.
and then I also get.
So have you tried this yet? Try index column equals unnamed 0. And don't forget that there's a space between the colon and the 0.
Okay.
When you have something cool to share it in Slack. And Brandon, I hope you're still listening at this point because lots of interesting things are happening here.
Is he actually on Slack?
No, this is a video recording.
Okay.
He asked me to record the class because he is taking care of the kiddos tonight.
All right, let me do this this dash for the first time without screwing it up.
mean, I fixed
Are you-
all the problems.
Are you getting an error message?
No, because I didn't do that part, and I cannot fix my model. It's like if I miss this part, and I can totally count it.
Do you want me to take a look at it?
No, I just fixed it.
Oh, you did.
Like,
Okay,
I
good.
mean, if I didn't put the onion here, it's
So
not
how
gonna
did
work.
you fix it?
The onion.
The index column is unnamed.
Uh-huh.
That's the code.
That's an easy one to miss for sure. Call me over if you want me to troubleshoot something, okay?
So the word control is used in two different ways in statistics. One is for testing. You give a random sample of a control group versus a treatment. That's something different, right? It's a random control trial. But in regression, with regard to your coefficients, you frequently refer to the coefficients as controls. So for example, if I go back over to the other notebook,
where I had my coefficients spelled out. So here, right? I was doing linear regression, and my predictors are aluminum, barium, iron, silver, etc. Right? Each one of these is a predictor. So I interpret all of the other predictors as controls. I can say the effect of iron on reflective index after controlling for the other 7 variables, or the effect of silver on reflective index after controlling for all of these other variables.
So if we include all the possible control variables into predictors,
Yes.
that's automatically. We can say that that's control. Is that-
I haven't heard it used in exactly that way, but the whole idea of regression, see, this is very similar to a correlation table, right?
Yes.
The only difference is that a correlation table doesn't control for anything else. If I were to do in here, if I were to do df.core, right? And I think df, it's not actually called df, it's called class. And then I was specifically to look at reflective index, which is the variable of interest, which would look like this.
Yeah, that's what I.
This actually looks like coefficients, doesn't it? If you look at these two things, this and that, they're quite similar. The difference is that this is the effect of, this is the correlation of NA on reflective index, but without controlling for anything else, right? And this is the effect of NA on reflective index after controlling for everything else. So regression and correlation is quite similar, but one is controlled and the other is not.
So when, like social science, in social science, when article says about these are control variables that we control, that means that they include these variables into regression analysis.
Well, again, I think it would depend on the article. If it's a scientific experiment, then in fact that might be referring to the control versus treatment.
It's not that.
But you don't think it's that. Then yes, it would say these are the control variables, means, or these are the variables that we controlled for, I've seen that, means these are the variables that we included in the regression as predictors.
If that's the case, this is like so specific, but I'm using disagreement data set.
Yes.
To find a project.
Yes.
And my target variable is going to be whether it's implemented or not. And then I did correlation metrics first to see how each features are affecting this target.
Okay.
And then found out strong correlation with target and then ceasefire. So, and I thought, oh, I need to control this because of course if you have ceasefire, it's likely to be implemented. I mean, is that really?
Yes, exactly. So there is a high correlation between two of your predictor variables. You might want to exclude or control for one of them, yes.
So I need to include this ceasefire for my regression.
Yes, absolutely.
Oh, I was going to drop this because I thought.
On that, you want to include it, yeah.
Gotcha. Thank you.
I'm going to give you one more example because you brought it up. If you look at the Titanic data set, we've got age, fare, cabin class, and whether or not they embarked. And it's a curious coincidence that if you boarded the Titanic in Cherbourg, France, you were more likely to survive, right? So a very simplistic analysis would say, oh, well, if you want to survive the boat, make sure you get on in France and not England, right?
Yeah.
But it's not like France causes survival and England causes death. No, it's that people who boarded in France were typically wealthier and therefore were in first class and were more likely to survive. So being French is highly correlated with being in first class. So you would definitely want to control for that. Because if you did just straight up correlation, you'd say, oh, well, you know what? As long as you're French, you'll survive the Titanic. But that's actually not the case at all.
I have a question. On what line of code did you call the data set in the application for the iris?
Great question. Let's take a look. So this is my iris dataset code. And it's kind of a cheat. My dataset is not a CSV file, it's a pickle file.
Oh.
So I use PD read pickle instead of PD read CSV. But it's the same thing.
Okay.
And I didn't have to pickle it, I just did.
That's what it was. Okay. So in theory, if I copy and pasted the link that I used in this for the Titanic one, then it should be good.
In theory, yes. As long as you put read CSV and not read pickle.
Because it's we don't have to do any data manipulation because you only need the file for you really only need it for graphing.
Yes, that's an excellent point. Yes, you only need it for graphing.
Well, in the application.
In the application. But if you removed the graph, then you don't actually need it at all.
And you really only need the training, like the X training for that. You don't need the whole training set. Or you need...
Correct. You never actually use the Y values for anything. Let me check Slack. Anybody have something to share yet? 9:07. Nothing?
So, at least you got the app.
I haven't done the there right now. So, wait. I'm using the same data, but instead of survive, then,
So right off the bat, this is going to be the
yeah. It's a binary, please choose another abbreviation setting. So, I would not use the different, because this one, then
accuracy works with the others.
Yeah.
Computer matrix should still work. I think it's your F1 score is the time number. It's like accuracy.
So either way, I did F1 score, this one still enough because they're both accurate, right? Similar, but the other one is more accurate, the F1 is more accurate.
F1 is a weighted accuracy score.
Okay. Ah, okay.
It gives greater weight when there are fewer observations.
Mm-hmm.
So again, going with the example of cancer, right?
Yes.
You have 1,000 patients, and only 2 of them have cancer. So you'll have a 98% accuracy, right? Just right out of running it.
Yeah.
So accuracy is misleading there. But if you give a greater weight to those 2 sick patients than the other 998, then you have an F1 score. It's a weighted
Oh, you
accuracy.
should concentrate on the smaller example for that 98, right? So for the, I would use F1 because I would concentrate more on the classification.
On the 2 cancer
Yeah,
patients, yes.
not the one without the cancer, right?
But if that's what you want to
Yeah.
treat cancer, you don't want to treat health. Yeah.
Okay.
Okay, sound good? But F1 only works with binary categories, it doesn't work with trinary categories.
Yeah, what's the question, sorry?
Yeah. No, that's what I'm here for.
So I first have to create.
I'm just rechecking and asking.
I first have to create a repo, right?
So you're doing this from scratch.
Correct.
You could create a repo, but then you'll have to move in profile and everything.
That's fine.
Okay, great. Then yes, create a repo, yes.
So I did this, and this is what I want to copy, but one at a time.
So create a new repository on command line. I wouldn't actually do any of those. Here's how I would do it.
Right.
So you've already created the repo in GitHub, right?
Correct. Just name, yeah. Just clone that.
That's the name. So go to the top. And just clone down the empty repo.
Okay.
Remove everything. Just git clone. Yeah, and it says you appear to have cloned an empty repo. This is true, but if you do ls-a, you should see it's not completely empty. It has a git folder, right?
Yep, there it is.
So you have to cd into it first.
first, CD as a tenant, and then as action. And it's got the git folder. So now go ahead and move all your stuff into it and do git push. Git add, git contribute.
So it actually looks like it's getting upset with the scale it's so it's going to have to scale and train distance. Upgrade them. If I split them and then scale, do I have to then scale them?
No.
So here's my
Let me take a look at this here. So you fit
split
your
with
scale and your dimensions are 17 or 9 by 7. Okay. I think X test scale, transform X test. What is the shape of X test? How many columns is it? Not rows but columns.
X test should be upset.
It's 10. And X train is also 10. Try this in a new cell. Let me think about this for a second. I was going to use a dot line instead of. Okay, I've seen this done 2 ways. You can, I have actually seen it done about others, not myself, where they scale the X test independently of the training test, and that works. Or the other is to use the dot apply method for every row of the X test to scale each individual row to the training
data. So this one,
data.
so this should work. This part's
That should work. And if you simply scaled the X test independently, you would be fine with that and would be able to proceed. But if you want it to be scaled exactly to the training data, to eliminate, to make sure that it is featured in the same way, you would want to think about this. You would want to write a function that would look like, and you want to try this in a new cell. So define apply scalar, and it's going to receive in parentheses row. New row is equal to train.transform row. Sorry, row dot, no, sorry. Train scalar dot transform. Train scalar dot transform. Okay, now run that. So it's a, now we're getting a new cell.
So search bar is two.
Virtually, just so we'll use it. It's always good to have scraps of code for later on. So your first row of data is xtest.loc. Xtest.loc bracket 0. Run that. See what it looks like. Is xtest a data frame? Or is it an array? You give me a tag xtest.
Okay, try I line instead of those. X, X, I. Just want to see what the first one is. There it is. So now try apply scalar to that.
Yeah.
Put all of that up where it is.
Well, how you doing?
There's no doubt about it. You try to unrotate all that up.
Well, he's your friend. Your friend. He's basically taking this, that bit into that.
Okay, put it into, put all of this into brackets, X, that's my line. Brackets, inside out. And I'm leaving that right. It is possible to apply it into an entire data, it's been a while since I did it.
So probably just
We did it the other day with a single row data, we were doing the baseball data set. Applied to an entire data frame. I have to do a little research before I do this. This is similar to it, or is it the same?
So otherwise there should be, no longer there's a train scale, it's still
No, I don't think it would be.
probably listed. Because
Mean your zero standard deviation. How are we doing, everybody? We are getting near the witching hour. It's 9:18. Anything in Slack yet? Okay, we've got a few here. Yao Lin on breast cancer.
Didn't change the model.
Okay, but you got some new fake data and it worked, and you predicted that they would survive.
Yeah, and
They would
got
die, right?
some, like,
That's right.
the other.
Okay. Now, I know German's working on an app. Is anybody else working on a Plotly Dash app for this?
I'm working on one.
All right, call me over if you want me to look at what you're doing. See if I can
Oh,
troubleshoot.
I'm troubleshooting. Well, I'm not troubleshooting now, but like I'm testing.
Okay.
And then Iris plotting.
Okay, so if you look at the error message, it's because you have missing data. Commands are in there sometimes. So you need to remove all missing data from your data set before you start creating. Did you also try and dissolve that sum? Under the parentheses. It looks like there's some missing data here. And a few others too.
This is the target.
Yeah, the target also has an element.
Yeah, and then I can draw that.
Did you do it inputs? Yeah. Yes, every time.
and then we should pick up the data frame is pickle should also be the scale. Actually,
Why are you picking the unit?
for graphic purposes.
Graph purposes?
Actually, probably should just pickle the.
It depends on your graph. The truth is, I did not do that with my Iris one because I actually wasn't. I wanted to pick the
Okay, so I could basically pickle the X train, the scalar, and the scale of the data frame would be the same.
I'm not sure if I'll.
So if I wanted to do graphical work off of the X train data set,
Yeah.
so just pickle that,
Yeah.
importing that up on, pickle my X train scalar, add that up on, and then just rescale it, which is transform.
You definitely could do that. If you're doing the visualization, most of the time people want to see it in the original measure.
So
Right? If you start seeing negative values on like a cabinet size, that's confusing.
yes. Okay, so probably the pickle the X train, and then if I needed to transform it or something, do that with that.
Yeah, I think that's how I would do it. Alex, you had something to show?
I'm stuck. So like, I ran this one.
Okay.
when I open up my application.
Actually, if you know, you can use it as a
Oh, I'm just copying and pasting.
yeah, so you actually
So
okay. So you have stuff, but it's not reactive.
it's not reacting the way I want it to.
And it's in Chrome.
Yeah.
So what do you think the problem might
I don't think I can figure it out. So I went here. So I opened my file. So that should be good. Not getting an error here.
be? What are you doing?
Oh, my logistic model.
Okay.
And then after I go here, I train data set. H1, I didn't touch the headers. I did ID equals male.
Okay.
And then min equals 0, max equals 1. And the step is 1 since it's a true or false. Oh, for
Now,
range.
keep in mind that changing the ID has nothing to do with the actual column. It's just in the app itself that ID.
I think it's just for range, for I in range 0, 1.
That would make sense.
Mark it. So that's the first one that's not right. And then this one would be in range 10 to 100. Sure. 10 is the first one I thought of, but I think there are a few that are less than 10.
Yeah, but that makes sense. It doesn't have to be absolutely max.
So that should be good.
For the male and female, you might consider not using a slider. Using
Yeah.
a radio icon instead.
Yeah, you
Because
can.
1.5 actually would be meaningful.
Mm-hmm.
But okay, as long as you do intervals of 1 though, so you're using step size of 10,
Yeah.
and up here using step size of 1, so yeah, that makes sense. That should work.
Okay, so that's what I did before. That was
Okay.
incorrect.
And does it run now?
Let me see. Looking for central routes. Stop. So, yes.
Something is happening.
So
Something is definitely happening. Right?
all right. So this one is good, and then I go down here. Now it's just this the graphics that are in doing what I'm doing.
Right, and the graphics are definitely going to be a lot more work, but if you could just get a balanced version, that's a good win.
Okay, let me try to do it.
Okay.
I'll try. I'll do the. If I can do the prediction, then I think I'll call it.
Sweet.
Should I just delete everything with the figures?
I would, yeah.
Okay.
Thanks. So still, yeah, how's it going?
I got tired and confused. And the combination of two exponentially, it's like,
Okay.
yeah.
Okay. I think we're all getting to the tired and confused point right now. But you have the building blocks to make success of it once you're well rested and fresh. Right?
What?
I think you do, yes.
I'll have something on Wednesday.
So, okay, I think I might have some issues with like, from where should I initiate this app? So what I did, I tried to use the skeleton of the KNN iris plotly.
Right.
So I copy pasted that code in a new app.py file in Atom.
Okay.
And saved that file under lesson 11 that we were, because I thought maybe I can call from there as well, no?
Yes.
Why would I? So, I saved my train data as a pickle, and I have a pickle
Sorry.
on the model as well. So I have both of these in the same folder.
Yes. Though keep in mind, you don't actually have to pickle the data itself unless you
Just
plan
the
on
model.
creating a visualization. You really
Oh,
only
yeah.
have to pickle the model.
Oh, yeah. Yeah. But now I need to change the setup layout because the
Yes.
KNN, it had like much more stuff going on, so I need to simplify it.
If you just delete all the graphics
Yeah.
and start with that, I think that you will find some success with that. Let's see here,
So I
Iris.
assume it's like
So I'm gonna pull up
a
the
lot of
Iris one
moving
right now.
parts, and I need to clear my head around like, okay, so what I'm actually going to show.
Like on this one, the real outcome is this sentence, right? And everything else, this graphic, it's pretty and all, but it's actually not necessary. So if you just cut off everything below this line and you only had this, that would be a very successful project. And it doesn't actually require any graphics and it doesn't require any data. All it requires is the pickled model. But it is 9:26, so we should start closing down. Get some rest, go home.
Basically.
If you'd like to give me some feedback, always welcome it. The exit ticket channel has not changed from where it was before. And on Wednesday, we will take a look at a new type of classifier. I'm not sure which one, but it's going to be good. Okay.
So you sound like the president. You're not sure which one is going to be good.
I hope I don't sound like the
You
president.
know that there was a
Yeah,
quote.
he's
There was a
not.
quote that we were laughing about today in regards to the stuff going on in Syria and Turkey. He claimed that he was
That's scary,
the
isn't
smartest man.
I saw that. It's just
Did you read, what was the quote? Did you remember the exact quote? Like, oh God. What does
I
this
mean,
man live?
this is. Don't get me started. Sorry.
Did you read the quote? Now?
Yes, I read the quote, and it sounded like the man was insane. I swear to God, it sounds like he's
He's
insane.
losing it.
Yeah.
Losing it, he lost it.
All right, Brandon. I'm sorry you heard all that. I'm turning this off now.